Okay, so far, what about off-path attackers? Is it possible for off-path attackers to do data injection into a TCP connection? Well, kind of want to say no, assuming they don't know the sequence number, because they can't eavesdrop and learn the sequence numbers. But if they could somehow guess or infer what sequence number we were going to use, then the answer would be yes. And that'd be really serious if off-path attackers could mount this, because now it's not just a few dozen people who are in a position to mount this attack, or a few hundred people who are locally within range of your Wi-Fi network, but it would be everyone in the world. So we really care about if off-path attacks are possible. So let's talk about this. This is called blind hijacking. Why would an attacker want to do this? Maybe they're replacing data sent by a web server, and so now they're going to start to copy your passwords on that website. Maybe you've logged in to a server, like by some kind of a remote connection with you're typing commands into that remote server, and you authenticated already. And if you authenticate once early in the TCP session, and then the server trusts the remainder of that TCP session once you're authenticated, then an attacker would love to be able to inject malicious commands into that existing TCP connection. Or maybe an attacker's just doing this to hide their responsibility and frame someone else so that they don't get caught. All right, so how would this work? The way this would work, actually, let me back up. The typical case for this blind spoofing is rather than injecting data into an existing connection, which might be possible, maybe the most basic thing to think about is creating a new connection from zero. Okay. So let's look at how to create a new connection from nothing, but fool the server about who's connecting. Okay. For instance, in the old days, it used to be that there were servers that spared you from having to type in your password when you connected if you connected from the IP address of your personal machine. Because they said, we'll remember that IP address is yours and we trust you, so we'll save you from having to type in the password. So that was called IP address-based authentication. Well, those were vulnerable. If you could do blind spoofing, then those would be very, very vulnerable. Okay, so in a blind spoofing attack, what we're going to do, the attacker is in red, is going to make the server think that there's a connection coming from this honest client 1.2.1.2. But it's not actually. It's actually coming from the attacker. So the attacker starts by sending a spoofed SYN packet to try to create a connection with a spoofed source address of the supposed client, okay? The client who we're trying to frame. Now, what's the server going to do when it gets this SYN packet? Yeah? Exactly. It's going to respond with a SYNAC. Thinks the client 1.2.1.2 is trying to connect to it. Whenever that happens, it knows to send back a SYNAC. It just automatically does that. Notice this is getting sent back to the client, not to the attacker. Now, the next thing the attacker wants to do to continue this and finish the three-way handshake is send the third packet in the sequence, which is an ACK packet, right? So what the attacker would like to do is send an ACK packet here, and then follow that by sending maybe some data. Okay? So what is the attacker going to have to do to be successful at that? They're going to have to make sure that their sequence numbers are correct, right? So can they get the sequence number in the ACK packet correct? In this packet, the ACK packet sent to the server, there's a sequence and there's an acknowledgement. Can they get the sequence number correct? Can the attacker get the sequence number correct? Yeah, because that's just one more than their initial sequence number, and they chose it, so they know it. Can they get the acknowledgement number correct? Not. It's hard to know. They don't know what number to use there, right? So this is going to be the challenge for the attacker. A minor note is that if the actual client receives a SYN-ACK and it didn't send a SYN, this client is getting an unexpected SYN-ACK, then it may respond by sending a reset back to the server saying, what's going on here? I don't even know, but it's not right. So the attacker's going to have to do all of the dirty work quickly before that reset arrives. But in some cases, there might be firewalls and stuff that actually prevents the client from sending back a reset, in which case we could take all the time in the world. Okay. So that's not a major barrier in practice. But the major barrier is that the attacker doesn't know the sequence number, the initial sequence number from the server. Because they don't get to see the client sent to the actual client because they don't get to see the packet sent to the client because the attacker's off path. So what is the attacker going to do to figure out what the server's initial sequence number is? How can they do that? Well, we have to figure out how servers are going to pick their initial sequence numbers. We haven't really talked about how they're doing that. And if you read the spec, the RFC for TCP, it says pick based on your local clock. It's like the number of milliseconds since 1970, and then you modulo 2 to the 32 or something like that. It says that way you know it's not going to repeat for a long, long time. Okay. So what are the security consequences of that? Can an attacker wants to be able to know what sequence number the server is going to use. Can they? Yeah? Yeah, if we knew the exact time on the server when the server sends the SYN-ACK, we could predict what initial sequence number it's going to use, right? We might not know its exact time, but one way to synchronize our clock with it, with the server, is for the attacker to open their own connection. The attacker can make a non-spoof connection to the server and see what SYN-ACK comes from the server, and that way they'll know exactly what the time was on the server. And then they can sort of like subtract for the round trip time or the latency for the packet to arrive and get a really accurate estimate of the time on the server. And then they can make a spoofed connection, and they'll now have, kind of synchronized their watch with the servers, so they'll get a pretty good idea of what the time on the server will be when the server gets their spoofed SYN and sends back the SYN-ACK. They may not get it exactly right, but they'll probably be within a few milliseconds, and so they'll probably be able to narrow down the possibilities for that initial sequence number to a handful of possibilities, and so they can just guess, and there's a significant chance they'll be right. Does that make sense? So what this is saying is that if you use the clock as your way to choose the initial sequence number, that's predictable. That's far too predictable. It enables the attacker to predict what initial sequence number the server is going to use, and that enables blind spoofing. Okay? So that means the attacker can now successfully mount this blind spoofing attack, because that was the main challenge for them, to know the right sequence number the server is going to send them. Now they can predict it without actually having to see it. Okay? So in the old days, all the servers were vulnerable to blind spoofing. All right, so now I ask you to think like a security engineer. How should we fix this? How can we fix this? You pick your sequence number, salt it. Okay, tell me more. How would you use a salt? How will that help? Take a hash of the local clock and use a salt in there. Do you want your salt to be public or private? Probably don't want that salt to be public, because then I think that we are back to the old problem again. Any other ideas? Yeah, I see a hand there. Yeah? Random. Yeah, I could pick it randomly. Every time if it was random, then the attacker is going to have no hope of guessing it. And opening non-spoofed connections doesn't help you predict what the sequence number for the next connection will be. Great. So random is great. Did anyone else have other things they were going to propose, or was everyone thinking random? I saw a couple other hands. Yeah? Do it based on their IP address. How would you base it? Like, can we get a little more specific about how we would derive an initial sequence number from the IP address? Like, how would you do it? Yeah, so we could do some kind of a cryptographic key-based derivation. So there's a couple of options. One option is random. Then you need a random number source, and it turns out those are not that easy. So then what's next is to use pseudo-random. What kind of pseudo-random do we need? It turns out ordinary pseudo-randomness is not good because ordinary pseudo-random generators are predictable. So what you really need is that cryptographic pseudo-random generator that we talked about in the cryptography lecture. So that would give you basically random. And another option is something that's effectively like pseudo-random, which is you could derive it from some data in a way that will give you unpredictable output that's kind of like pseudo-random. So for instance, you could take a cryptographic, let's say hash function of the source and destination IP address and the source and destination port and maybe some cryptographic key and maybe the time. And that way, as long as there's a crypto key in there, it's effectively acting like a pseudo-random generator. Okay. So basically, we make it pseudo-random so it's unpredictable, and then this blind spoofing attack is no longer possible. So this is an old attack that's no longer possible today.